Hello everyone, my name is Abhishek Sharma. Currently, I am doing an internship at Deep2 Foundation. It's a 6-month internship, and now I have completed about 3 months. So we are working on a computer vision-based railway carriage component detection system using YOLO. So why this project? Uh, this project is all about detecting safety critical components like axle cover, springs, wheel, brake hardware, and hose connections. Upon that, we are also checking if those components are missing or not. So why we need to check this? For example, the cost of wheel is very high. The wheel is very costly. So if we fix these critical components in time, we could save a lot of money. So, and upon that, manually inspecting this component is tough and error prone. So that is why we are trying to solve this problem using YOLO and computer vision. So what this phase set out to do? There are 4 phases. First is extracting frames. So to solve this problem, we need lots and lot of labeled images. But we don't have that. And there aren't available photos too. So what we have done is we have videos. So what we have done is we have extracted frames of that videos using OpenCV. After that, using RoboFlow, we have annotated those extracted frames, and by uploading those labeled dataset on Kaggle, we have trained a model. So the end goal is to build a scalable workflow. Like in real time, we could track those missing parts or detect those parts. From raw video to verified dataset. So obviously, first one is frame extraction. OpenCV pulls still frames from the video, and second one is annotation. There are 8 classes which we have annotated, and at the end, model training, and at last, human verification. So what are those 8 classes that we are detecting or checking whether it is present or not? So I personally have annotated about 100 to 500 frames on RoboFlow. So the 2 classes of pairs are deliberately split into normal state and defective. For example, axle cover. So we are also checking whether that axle cover is missing or not. Upon and springs is present or it is missing. We are checking both the normal state and the defect state. And other components are engine wheels, handbrake, hosepipe, wheels. So there is one confusion. I need to discuss this with the other team. So we are told to annotate only wheels. So after merging their label dataset and my label dataset and everyone's label dataset, I could found that there is engine wheels too, which I had not known earlier. I need to discuss about this class with my team. So I will talk only of 7 classes. So the team is training this model on YOLO 26, but I have independently worked on YOLO V5, and also just to check it whether the data qualities are fine or not. That's it. So what I found is that MAP 50, I found it 85.6. Whereas I found MAP 50 to 95 is 57.5, which is lower, that is obvious because MAP 50 covers MAP 50 covers 50% of the. For example, if there is a true box around an object, and that object and while predicting it covers 50% of that space, then it is considered good. So that value is MAP 50, which is 85.6, and MAP 50 to 95 is 57.5 because it considers MAP 50 considers 50% of the overlapping values, and MAP 55 covers 55%. Likewise, MAP 80 to be true, it must cover 80% area. So like that's why MAP 50 to 95 is lower. And another thing, recall is 90.8%, which means almost every defective parts and missing parts is detected by the model. And precision is 72.6, which means of all those detected defective parts, some good parts or some good items are also classified as defective. So we must try to increase this precision, but it is I think this doesn't matter in this project case, because this defective detecting manually inspecting an extra parts is cheaper than missing a defective item. And what is per class performance of MAP 50? Yeah, we can see axle cover is 95%, handbrake is 98%, and hose pipe 92. These all these is higher values because we have labeled so many data set, and axle cover miss is lower because we have not labeled many data set of axle cover miss. Also, engine wheels, I am confused here because earlier we are only told about 7 classes. Here engine wheels came in the data set. I need to discuss this with my team, and I can explain about this in while in next trimester. So Excel cover, we have 217 images whose MAP 50 0.95. Excel cover miss, we have only 13 images. That's why it's MAP 50 0.53. And for springs broken class, we have zero labeled images. That's why it is not evaluable. So our next focus must be to level maximum of springs broken level. So another thing we have done is that human in the loop annotation. For example, we have labeled 100 dataset. So now for leveling and other datasets, what we will do is we will ask the model itself to level it in RoboFlow. After that, we will verify it. So in this way, we can save time. So what we'll do, new frames extracted, YOLO 26 pre-annotates, team verifies and corrects, and fits next running round. This is how it works. So status and what next? So frame extraction pipeline built with OpenCV. We have done that. Personally, I've annotated about 100 to 500 frames. Independently, YOLO V5N model is trained by me, and the team is working on YOLO 26. Yes, this is contributed to team's YOLO 26 training. And active in annotation verification workflow. This is just we have started active in this one, human in the loop annotation process. This was just introduced to us, and we are about to work on this from now onwards. So what we are planning, other things, is that prioritizing annotating defective class like missing parts and broken things. Then contributing next YOLO 26 returning round, and evaluate YOLO 26 once team metrics are now. Currently, we aren't provided YOLO 26 team metrics, so we will evaluate this after they provide us. So, and at last, keep verifying model generated annotations till it becomes scalable. So that's it. This was my project at Deep Duo Foundation. So now we have more 3 months to work on this project. Thank you.